Okay. Now, the next special case is to look at the eye. And the eye typically, well, you can read about the construction of the eye. Where this is useful in our day-to-day life is looking at, for example, if our eyes need any correction. Now, when we're looking at any corrective eyeglasses to help to correct our vision if your vision has some flaws. I know mine is pretty, unfortunately, noteworthy bad. But we're going to mimic, okay, what do we need to do? Well, we're going to look at the far point at which things are comfortable, and ideally, the eye should be able to comfortably focus on things infinitely far away. If it turns out that your eye cannot focus on far objects, then we're going to need to adjust to bring the image close, to find out where the useful far point is, and to bring that image closer. In the same way, we're also going to track the near point, and the near point is where, how close can something be to your face before you can comfortably read that. Again, as we're correcting for, if you have the inability to see things too close to your eye, we're going to try and correct that by having your eyeglasses move your effective near point, so that your comfortable near point contains stuff you want to look at. Now, in an eyeglass, for a lens for one eye, typically that is one lens, and that one lens will have a focal length. Well, and that focal length will be in units of distance. Often, let's say centimeters. That's a reasonable scale. Now, the power of a lens is given as 1 over the focal length of a lens. And so the units are 1 over length with the units with the D giving a measure of diopters, which are inverse meters. And also, if you're looking at like your eyeglass or a friend's eyeglass prescription, then the eyeglass prescription will say something on the lines of like P equals -4. And feel free to criticize them for not keeping units, but often they won't, because the units, using units of diopters, are now so near universal that people will actually, out of laziness, skip that so that they cannot get that passed. So, the near point for normal vision is considered to be 25 centimeters. So that if you have, well actually let's see, if we have this, take this a power of, 4 of -4, that means that I have a focal length of 0.25 meters, or 25 centimeters. Now, a power of 0, or normal vision, means that you have a focal length of basically infinity, which means that you just have a flat plane of glass, which means that, hey, you don't need anything to help you. The focal length of this would be 25 centimeters, and the sign, negative or positive, describes whether it's correcting farsightedness or nearsightedness. And there are a couple, I'm having a bit of a problem with the sketchiness of the camera today, so I want to make sure I can finish a couple of things. But the examples 24.4 and 24.5 both address one of each of the two things you're going to commonly see pretty directly.